Welcome everyone. Welcome to Scaling Argo CD from symptoms to solution. My name is Alexandre Gaudreault. I'm from Quebec, Canada. I'm a software engineer at Intuit and also an Argo CD maintainer. So let's talk a bit about Intuit. Intuit is one of the reasons I'm here today, and Intuit is also the company that took the bold decision a few years ago to open source Argo CD, and also open source a couple of different projects, so go check them out. So today the agenda is quite simple, but it is an advanced talk, so you need to be familiar with Argo CD. You need probably to have deployed it, and if you have not, don't worry about it. It's also going to provide you good tips to investigate scaling issues that you might have in the future. So we're going to go over a list of different scaling problems that we've experienced, or that I've experienced, the community have experienced, and we're going to look at the symptoms. We're going to look at the graphs and see what happens in Argo. Normally, people will just mitigate the symptoms and be done with it. But today, we're going to dig deeper. We're going to try to diagnose them, find the root cause, and fix it for good. So let's talk a bit about the Intuit platform for a second. At Intuit, we have multiple instances, and our instances have different footprints. So we have instances configured with 5 and 10 clusters. We have other instances configured with 300 clusters. We have instances using monorepos and application set. Other instances are using applications, like straight applications, and have a lot of them. So these variety of instances allow us to experience different scaling issues and make sure Argo scale in general. The most common scaling issue that you've probably experienced before is this one. So you're on call and you get a CPU alert. You go look at your CPU request in your chart, in your graphs, and you get something like this. So you have two choices, right? You can bump the CPU request, which I'm sure you've done a couple of times before, or you can decide to investigate it. I see a lot of people laughing, so I'm not the only one. Or you can investigate, why is the CPU that high? Is Argo supposed to be like this? So yeah, sorry about the light, but let's try to understand where the CPU is consumed. In the application controller, there are 3 main components. The first one is the GitOps engine. The role of the GitOps engine is to watch all the resource updates in your connected clusters. The GitOps engine will then evaluate if that resource belongs to an application or not. If it doesn't belong to an application, it will discard it. If it does belong to an app, it's going to cause the reconcile loop. So the role of the reconcile is to figure out if your app is out of sync or not. For that, the reconcile is going to reach to the repo-server. Most of the time, it's going to be in the Git repo is going to be in the cache, so the connection to the repo-server is going to be quite fast. And it's going to compare that with your Kubernetes manifest also in the cache. It's going to compute ignore differences. So there's a lot of CPU time spent in the reconciliation. And if your app is out of sync, well, whether you have auto sync enabled or you manually trigger a sync, the sync loop is going to kick in. The sync loop, it doesn't happen quite often, obviously. And the sync loop is mostly I/O bound, because it's going to call the Kubernetes API to apply the resource. If you don't trust me, you can profile your application with pprof and get exactly which method are consuming the CPU. So you use pprof, you get a flame graph like this, and you can investigate deeper. But today we're not going to go too much into pprof. You'll have to trust me. So it's on Sunday. We get the iCPU alert. We go look at the reconciliation activity. And we see that we have a constant rate of 32,000 reconciliations. Now that's weird, right? It's Sunday. No one's supposed to be working, except us, because we're on call. And so we know that people are not deploying. We know that people are not syncing. They're not changing Git. Why is Argo doing that much work? Well, we've seen that the GitOps engine watch everything and then it causes reconcile. So let's try to improve that filter so we have less reconcile events. So there's two ways we can do that. The first one is to exclude the resource. If Argo is watching resource that we never see in the Argo UI, we never deploy in our applications, we can exclude that. Argo doesn't need to watch them. If it does need to watch these resources, then we can ignore parts of it. So we can configure the ignore resource updates. But the hard part is to try to figure out which resource are actually causing the reconciliation. For that, it's all documented in the Argo docs. So I'm not going to go over the steps in detail, but we need to enable the bug logs. The reason why, we don't want a constant rate of 32,000 logs to say which resource is triggering updates. The log or the Splunk team, they're not going to like that. So we enable debug logs for maybe 30 minutes. We get enough data to know which resource are causing or reconcile. And we figure out that at Intuit, it was actually the HPA, the horizontal pod autoscaler, that's causing a big chunk of the reconcile. Why is that? So if we think about the HPA, we know that the HPA is going to constantly reach out to our metrics or monitoring system to get some value and then try to compute if it should increase the number or lower the number of pods. And it's going to persist that in the HPA status. So whenever it persists that in the status, it causes a Kubernetes change that the GitOps engine received that change, will evaluate, is this resource part of my application? Yes, trigger reconcile. Now we know that any change to the status shouldn't cause our application to be out of sync, right? Because we don't commit our status part of our desired manifest. So we try to configure ignore resource update to ignore all the status. And let's not just do that for the HPA, let's do that for all resource. So we do it for all resource, we deploy that, and we now get our reconciliation activity almost dropping to 0. We can see little bumps, but we know that these bumps are caused by our reconciliation timeout because they fit with the reconciliation timeout. So every 3 minutes, we have a little spike of reconciliation, but that's a good improvement, right? So we deploy that, and now our CPU looks like this. What was a constant rate of 6 and 7 CPU, 6 and 7 core, is now just spiking a lot. And spikes aren't that bad, but we know that spikes will cause stress in our system. At a specific moment, our system needs to do a lot of work. And in a distributed system like Argo, well, that can affect other components. One of these components is the repo-server. So I've said earlier that during a reconcile, it was going to reach to the repo-server, but most of the time, it's going to be in cache. So it's blazing fast. But the cache expires. If the cache expires and you try to reconcile everything in your Argo instance, well, you're going to have a spike of activity that is transferred to the repo server, and the queue of the repo server is going to fill up because it's not in cache. The operation takes some time. It needs to run Helm, customize, and this may take a minute. And you might have an autoscaler configured. So if the queue of the repo server gets filled up, well, you just scale more pods. The problem with a spike, you do all the operation at the same time, and the autoscaler is going to come after. So the repo server is going to accept all the requests that it puts them in queue. Maybe they're going to process these requests in 45 minutes. So you don't want that. And then the new pods that are scaled up by the autoscaler, they're just going to have a small amount of the request, because by default, how does it work when you route requests in Kubernetes? It's round robin. So the pod was there at the beginning that the queue is full. There's like 1,000 items in the queue, still receive requests because it's just doing a round robin. So spikes are bad. It puts pressure in different components in your system. You want something that's steady and predictable. There are some mitigation options to reduce the spikes. So you can configure the reconciliation timeout to be an hour or two. Now, it's not going to fix the issue. It's just going to delay it. If you do that, you also need to configure the Git webhook, because you don't want your application to be out of sync an hour after you've committed. You want the GitHub event as soon as the commit is made. And you must configure the manifest generate path. Now, this is mostly used for monorepo, but you should also configure it for a single application. If you have a Jenkins file, if you have a CI, a README, you don't want a README update to cause a reconcile in Argo. That's unnecessary. And if you use monorepo, you absolutely want to configure this annotation, because if you have 1,000 apps that syncs the same repo URL, whenever there's one commit, it's going to cause a spike, because there's 1,000 apps that are going to be reconciled at the same time. But we said we're not mitigating issues today. We're fixing them. So fixing it is actually quite easy. You just configure a jitter. Now, what's a jitter? At the end of the reconciliation timeout, it's going to add an amount of time that's a buffer. So let's say you have your reconciliation timeout is an hour, and you configure the jitter to be 30 minutes. You now have the guarantee that your app is going to be refreshed between an hour and an hour 30 minutes. So instead of having a spike at an hour exactly, these requests will be spread over 30 minutes. So what if reconciliation is still high? You have different things that can cause high reconciliation, but I'm already behind schedule. So let me see, raise your hand if you use Orphan resource monitoring. Okay, some of you, so I'll go quickly, but I'll be at the Argo booth after for your questions. But basically, Orphan resource monitoring is going to cause an update whenever there's a resource in the namespace that changes. At the beginning, I said the resource needs to be part of your application. Well, with Orphan resource monitoring, it's not true. It just needs to be in the same namespace. So if you have random resource in your namespace that you don't know about them and these resources change, then the reconciliations are going to go up. So if you, for the ones that use Orphan resource monitoring, try to turn it off and see what happens. Someone in the community tried that, and they posted their graph on a GitHub issue, and that's their reconciliation activity after disabling it. That's their CPU activity after disabling it. So we can see that the CPU and the reconciliation activity are almost the same. So there are some limitations. We don't have time to talk about them. Let's do a little recap of what we've learned so far. So we've learned that there's a strong correlation between CPU usage and reconciliation activities. So if you want less CPU, you want less reconciliation. To have less reconciliation, you can ignore the updates you don't want. We've seen that spikes cause problems, so you want a smooth CPU. You don't want spikes. So you can configure jitter to smooth that out. And we haven't seen that Orphan resource can be very costly. So we fixed the CPU. What's the next alert? High memory alert. We go look at our memory usage, and it looks like this. For the people in the back, it looks like this. So we've reached about 100 gigabytes in our application controller. Why is that? We're not going to bump the request at this point, because Orphan may not even be scheduled on the node. So what's consuming the memory? Well, we've talked about GitOps Engine, and we know it watches all the cluster. Well, when it watches a resource, it keeps that resource in cache. So as you add cluster in your Argo instance, the cache is going to grow, and the memory is going to grow with it. So how can we reduce the memory? Well, we can watch less object. Again, we can exclude what we don't need to watch. There's another setting that we often don't think about, and it's the cluster namespace filter. Now, if you have a cluster that has 100 namespace in it, and you only deploy in 5 namespace in that cluster, well, don't watch all the namespace in the cluster. You can configure it to only watch 5 namespace, and you'll get a 95% memory improvement. Another way to configure that is by using respect RBAC. So instead of configuring in Argo which resource to watch, you configure your role and role bindings, and Argo is not going to watch the resource that it doesn't have permission on. And realistically, if we configure all that, how much memory do we have now? Maybe we have 80 gigabytes. That's still a lot. So our last resort at this point is sharding. How does sharding work? It's simple. You split the application controller in 2 shards, and either with round robin or a uniform distribution, your cluster are going to get assigned to a specific shard. So right now, it may look like this, but it may also look like this, because we're doing a uniform distribution. We're doing round robins. We're not sharding based on the cluster memory footprint. And our cluster are not all equal. We have production clusters. These production clusters will have a lot of resources. If we have test cluster, maybe they won't have as much resource. But for Argo, they are 2 clusters. They're the same. So what can we do about it? We can manually assign cluster to specific shards, so we can recalibrate our memory usage in our shards. There's another project that's pretty cool. It's called the Argo CD agent. I don't know if you've seen the talks about it today, but it's also going to be a way to fix this issue in the future. But right now, we have manual assignment. We manually assign our cluster to shards, and we spin up multiple application controller, and we get something like this. Now, 15 gigabyte is not that bad. It's much easier to schedule. We're proud of ourselves. We can go to our Sunday brunch, and then we go to the office on Monday, because some people need to go to the office, and someone tells us, hey, Argo is slow. You've heard that before? Realistically, of course. It's a tough one to investigate. Why is Argo slow? There are many things that can go wrong, but today we're interested if all our applications are slow. Is it only one specific app, or is it all the applications? There are a few questions we can ask. We can check if our work queues are actually filling up, or if our items are being processed. We can look at our external dependencies. So we have 2 big ones in Argo. We have Git, and we have Kubernetes API server. So let's look at our queues. If our queues looks like this, that's bad. Queues should almost be 0. So there's one thing that may cause Argo to be slow globally. It's still related to CPU. I don't have time to talk about it, but go watch this talk. It's about CPU limits and throttling. It's super interesting, but there's dozens of talk on CPU limits. But basically, if the CPU gets throttled, your operation takes more time. So what you want to do is increase the CPU limits, or you may want to consider removing it totally. So let's assume low reconciliation or CPU is fine. We can configure increasing the number of parallelism in Argo. So we have the status processor for the reconciliation, and we have the operation processor for the sync. Now, I'll say it one last time. If your CPU is high, don't increase that. If Argo is there and you try to increase the parallelism, it's not going to go well. So another thing is, as said, we have to monitor external dependencies. So one way to do that for the interaction with Kubernetes is to look at the audit logs. So Kubernetes will produce an audit log for each calls to its API. You can use the user agent Argo CD application controller, group all those requests, and you can see if any kind is using a lot of the API calls. That happens because when we interact with Kubernetes, we have a client-side rate limit. So if one kind is using all the API call because there's a problem, we're going to get client-side rate limited, and everything is going to be slower. So in Argo 3.0, we added the client-side metrics, so now it's easier to monitor if we're being rate limited or if we have latency when interacting with the API server. If we do, you can configure any of those metrics. Now I'll try to explain why we added the client-side metrics. Do you remember earlier when I said to optimize memory, you can configure the cluster namespace filter? Well, that's what we did. Before we were watching auto cluster, so let's say there's 100 kind in your cluster, we were making 100 API calls. Now we've configured 6 namespace in that cluster, so now we're making 100 API call per namespace, and we're now making 600 API call. You can see that the max idle connections is 500. So by just changing our memory and how we use the memory, we've now reached, well, we are now over the limits of the default 500, and this created another bottleneck when we were interacting with the API server, temporary deadlock until our connection expired. All right, so that was a lot for today. I'm running out of time, but this isn't even half of the scaling issues you can encounter. There are a lot of different possibilities where Argo won't scale, because whenever you fix or configure Argo, whenever you configure some Argo settings, and you fix the bottleneck somewhere, the pressure point goes at other places. So you always have bottlenecks in your system, and you need to address them. Now, I'm sure some of you have learned about new settings here that you're not using, and you're excited to configure them. Configuring the scalability in Argo CD is like trying to pour the perfect espresso shot. Now, I drink a lot of espresso. You never change all the settings at the same time. You change one setting, you pour a shot, you taste it, and then you iterate on that. If you try to change all the settings at the same time, you won't like the taste, and even if it tastes good, you won't know why. So if you've experienced, one last thing, if you've experienced scaling issues and you fix them, we're interested to know, so you can reach out to SIG Scalability, or you can reach out to me specifically. And if you have questions, I'll be available after this talk at the Intuit booth. So thank you, everyone. Thanks for listening, and I hope you'll improve Argo performance. You have all reference.